Hey, this is Steve with PageKey Tech. Welcome back to OS14, where we're organizing our OS code. Much needed, and hopefully it'll help us develop future parts of our OS a lot faster and more efficiently. So the overview today, first we're going to run the OS and see what looks different, which is not much. Then the main changes are to kernel.c and the makefile, other minor changes, some lessons learned from this, and the file tree and the code diff, which we'll see on the screen. So here's what the OS looks like, pretty much like it did last time. We have ls, no file system. We have help now, which tells us we can do ls clear and VGA. And if we say VGA, it's also not implemented. So not too much going on here, but it still works even though we moved a whole lot of code around. And that's it. So the main changes here, first of all, we split kernel.c into subfiles because I found when I went in to try to do something, it was a massive kludge, just basically spaghetti code. Too many different things that were unrelated stuck together in one place. So kernel.c is now split into common, kernel, and screen, each with its own headers and source files. We had no header files before, it was just all stuffed into one C file. Additionally, we rewrote the makefile to be more modular and much more maintainable. Each of those little sub packages has their own MK makefile that is included in the main makefile. Other minor changes include that we fixed the ISO build in Docker, which I didn't even realize wasn't working. We just had to install an additional package. Renamed bin to scripts because bin is a little misleading, and added a VGA stub that you saw when we ran the OS. So maybe the next video will be about VGA, but first we had to make some room for that code. Lessons learned for this video, two main ones. First of all, recursive make considered harmful. There's a paper out there on that, and everyone seems to have a lot of hate for recursive make, where you have a separate entire make file in each subdirectory. Instead, you're supposed to use the include directive and pattern matching. So we'll see that in our code and how I did that. Also, header files are pretty cool. I guess I get why people use them now. So the header files are never actually used in the build commands, but somehow GCC figures out where they are and how to resolve those references. The references seem to be relative to the source file. So if you have a reference in kernel.c and you're looking for something in a directory up, you just do .. whatever you're looking for. Accidentally, I had stdlib.h in the same directory as my source file, and when I tried to include it without the .. it went and grabbed the system standard lib, which we don't want, and that caused a whole bunch of errors. So be careful with that. I guess if there's a name conflict, you need the .. to make it grab your own header file. Of course, this is all probably really simple C knowledge that I should know, but I'm really not a C or C++ guy, but maybe I'll become one. Now let's take a look at the file tree, and then we'll jump into the code diff. So taking a look at the differences between the previous video and this video as far as file structure, the top level, there's really no difference other than renaming the bin folder to scripts. Once we get into source, we start to see some of these nice changes. Previously, source just had all this stuff inside of it, just random files. Now we have the boot folder, which actually contains code for our bootloader that we did in the beginning of this series, and this is actually not used at all. If you delete this folder, you will still be able to build the kernel. We have common with our makefile, standard lib.c, .h, and types. Kernel has our GDT, our assembly file, our C source file, an H file, and the keyboard map, as well as something to build it with. And screen just has an assembly file, a C file, and a header file. That's about it. Everything's nicely compartmentalized. And we can see that kernel.c is about 40 lines shorter, so not too much shorter, but hopefully it'll stay about this length even as we add more complex features in other files. So here are the changes from the previous video. Just a handful of commits here, nothing big. Shuffling around where the build files are, they're built in place now, and we ignore those files, and there's really not too much going on in the build directory anymore. We added gdb and grub_pc_bin, which were missing. This is for making sure the ISO builds properly, and gdb is obviously for debugging. And the makefile's been pretty much completely rewritten. Basically, we have nice generic names for pretty much everything. We define build extensions that we use in the clean to delete the things that were built in place. We define our C compiler and its flags, the linker script, and the kernel out and ISO out. So these are the two main targets that we're building. We have some global variables that are used in these include files, the object files, and the bin files. So I changed it so that anything that is a C file creates an obj file or a .o file, and anything that is assembly creates a .bin file. I don't know if that's correct convention, but it's how we're doing it for PCAS. Then we include those three files, which we'll see in a second, and we have some very generic rules for how to build the different parts of our system. So every .c file is going to have an out file, a .o file, And the rule to build that is to just use the C compiler with the C flags, and you have this special symbol that means the input file. So this is going to substitute whatever.c, and then the output is $@, which is whatever.o. Same thing for the bin file, where we take ASM files and we turn them into bin files using NASM type F32. So we've pretty much just generalized what we had going on before. Then the kernel out, our main executable here, is going to take all of the object files and all of the bin files and link them with our linker script and produce that output of kernel out, which is pcos.bin. And then the ISO uses that kernel out to do a grub, make, rescue, all that stuff. And down here we have the run commands, and they're all marked as phony now because they're not actual file names that we're producing. All makes the ISO clean, cleans everything up. Debug is kind of interesting because it adds a C flag and then just builds the ISO just like all does. And then all of the run commands are pretty much the same. Fixed a link in the README, just noted that none of the stuff in the boot directory is used at all. And then here we get a taste for what those MK files look like. We just add on to the object files the output that we're looking for. So there is a standard lib.c and a standard lib.h. Together, those will create this standard lib.o file. So we don't actually need to know anything about the C or the H files. That rule that we wrote about the .c file will pick up the .c file and turn it into a .o file automatically when we go to build pcos.bin. And then we just moved this really crappy string equals function into standard lib, and I'm assuming we'll probably want to add some more things in here. Since we're running on bare metal here, we have to write our own functions for all these convenience things, and types also booleans and trues and falses and things like that. Big deal. And all the headers now have header guards too. Kernel.c, not too much new except that we just deleted a ton of stuff and moved it out of here. And I improved the IDT explanation just a bit because I was there. And we added the VGA and the help functions. Kernel.h was just stuff that was moved. Keyboard map added a header guard. Here's another example of the MK files where we have the bin file that is going to take kernel.asm and produce kernel.bin. And then we already talked about the .o files. Same thing for screen. Yep, that's it, just reorganizing code. So that's all that's changed from the last version. Thanks for watching this OS video. Stay tuned for the next one.